Hi there. And here we are again. We're going to show you how to use discrete mathematics, notably vectors, and the idea of independent vectors and coefficients and components to account for the phenomena we observed with polarized light. So if we want to represent the light itself, if we want to represent it in a vertical polarization, we use a vector 1, 0 like this. If we want to represent it in a horizontal polarization, we use 0, 1. That's the two bases, the two independent bases that we use to describe the two independent states of the light, two possible independent states of the light. Now, the light can be in either one of these pure states, in which case if we measure it, we keep getting the same answer again and again. It's repeatable. If we measure the light with a vertical polarizer and it comes through and it's vertically polarized, and we keep checking it as vertically polarized, it stays that way. It doesn't vary. And if we measure it with a horizontal polarizer, it doesn't come through. It's all in a pure state of vertical polarization. Now, we can also have a combination of the two states, and that's what we talk about. That's what we mean by a superposition. For example, if we have D1 as a coefficient for our vertical polarization, and then we have D2 as the coefficient for our horizontal polarization, this is a combination state of the two different polarizations, and D1 tells us, it does not tell us the probability directly, but D1 squared is the probability that we will see the light coming through a filter that filters for that type of light. And D2 is the probability that it will be absorbed in this type of situation. This is a superposition. When we measure it, we get D1 or D2 in a probabilistic type of situation, meaning that if we think about it in terms of individual photons, and we can do this experiment with individual photon at very low intensity, then the probability of a photon getting through the filter is D1 squared. And if you measure individual photons, you'll get a stream of them, but after a certain amount of time, the probability will converge on the D1 and D2. Now, how do we represent the filter? The filter is represented with two vectors. It has one vector that shows you whether it is transmitting, what it is transmitting, and this particular filter that I'm writing down now is going to be transmitting vertical light, and it is going to be absorbing horizontal light. So that is the way we represent a filter that transmits all vertical light. And if we want a filter that transmits all horizontal light, then the left or the first vector is a 0, 1 to indicate that the transmitted base, the transmitted type of light, is a horizontal type, and the absorbed type is a vertical one, so the second vector is 1, 0. And then we can have everything in between. We can have angles. If we have an angle, a filter that is at an angle, then it it looks like this. If it is at an angle of, say, alpha, then the first component is cosine alpha and minus sine alpha.